Hey there, in this video we're going to just do a couple modeling problems. Our first one here says that the entire area of a square garden and a 3-foot wide walkway surrounding the garden is 18,000 square feet. Determine the dimensions of the garden. Looking at that 18,000 number, I'm thinking, hey, probably need a calculator at some point here. And let's just, first you want to make a picture. Okay, so we've got a square garden whose dimensions we don't know, right? And then we've got this walkway around the garden that's 3 feet wide. So I'm gonna draw that in a different color here. So like, I know kind of this distance there is 3 feet, which means that's 3, etc., right? But what I don't know is the length and the width of the garden itself, or of the whole thing, which is that which I do have the area is 18,000 square feet. So I'm going to call something X. I'm trying to find the dimensions of the garden, so why not call the width of the garden, which is also the height of the garden, let's call that X. And so what that means is my entire length, or length and width of the whole thing here is going to be X plus 6. Right, 3 on each side, 3 feet on each side. And if I know the area of that kind of orangish square there is 18,000, then we have the equation x plus 6 times x plus 6 equals 18,000. This is an equation we need to use our calculators to solve. We can expand this out at least. We could set it equal to 0 even. 17,964. And then maybe you'd use quadratic formula on your calculator. You use the solve feature, solve it by graphing, which is going to be a separate video. But when you do solve it, you will find that x equals 128.164, or x equals negative 140.164. Well, that obviously we can't have a negative length there, so the dimensions of the garden are 128.164 feet by 128.164 feet. All right, for our second example here, we've got everyone's favorite mixture problems. When I try to think these through, the first thing I kind of always go back to that I think helps me is really trying to remember this idea of a quantity times a percent plus a quantity times a percent equals a new quantity times a percent. And for most of these problems, that'll work. Sometimes when you're taking something away instead of adding, you have to think about subtraction. Sometimes you have to really work on what quantities you know and don't know, but for the most part, this is a pretty good template. So let's think about this. We're starting with 5% orange juice, and it's sort of hidden in the language here, but it means we're starting with 900 gallons. 900 gallons, 5%, because we're going to add pure orange juice. And anytime you see pure in these mixture problems, that means 100% OJ or whatever, 100%. Okay? And so I can see right now I've got an initial quantity of 900, and that is at 5%, 0.05, plus some amount, I don't know how much, but some amount of pure orange juice, and it seems right that I should write it in orange there. Okay, some amount of pure orange juice, 1.00, right, 100%. You don't have to write that, but I like it there. It reminds me what I'm doing. Equals my new quantity. Well, how much is my new quantity? It's the old quantity plus what I added, 900 plus x. And what percent do I want? I want it to be 10%, right? So original, new, result. Now I just solve this. Do some math. Let's see what happens. Pause it, solve it, see if we match up. Hopefully you got 50 gallons is what we need to add. All right, thanks for watching.